Assalamualaikum. My name is Farhana Adlina. Today, I would like to present my final year project on the degradation of methylene blue using calcium peroxide. Now, let me introduce to you what is methylene blue. Methylene blue is one of the organic dye used in textile industry that contributes to the dye pollution in water source. Regarding to this problem, one of the methods in treating the dye wastewater is by the degradation process, which is also known as oxidative treatment. Basically, oxidative treatment is a chemical treatment to remove organic material in wastewater by oxidation reaction with hydroxy radical. In this research, calcium peroxide is applied in the degradation process due to its ability to release oxygen and hydrogen peroxide. As you can see from the first picture is the methylene blue solution, and in the second picture is calcium peroxide powder. The objective of this research are to investigate the various parameters such as the amount of oxidant dosage, pH and temperature on the degradation rate, and to calculate the degradation efficiency of calcium peroxide on methylene blue aqueous solution. Next, we move on to the methodology. Firstly, 10,000 ppm of methylene blue stock solution was prepared. The solution was further diluted to 10 ppm. After the dilution, 2 ml of copper catalyst and 0.2 gram of calcium peroxide powder is added into 100 ml of methylene blue solution. Then, the solution was placed into a water bath shaker and agitated at 100 rpm to conduct batch studies of different parameters. The sample then was withdrawn from the flask every 30 minutes in duration of 3 hours and measured under the UV vis. Then, it was repeated by varying the pH at 3, 5, 9, 11 and 13 and at different temperature, which is 25 degree, 30 degree and 35 degree, while other parameters are kept constant. Lastly, the degradation efficiency is calculated and investigated. Moving on to the result and discussion. These parameter studies were carried out at 30 degrees Celsius at 180 minutes and they were agitated in water bath shaker at 100 rpm. The first section is on the effect of oxidant dosage, initial pH, solution of methylene blue, and the last section is on the temperature. Firstly, the effect of different dosage of calcium peroxide is studied. Based on the graph, the increase of calcium peroxide dosage will increase the degradation rate of dye solution. As we can see, the highest degradation efficiency was noted at 1.4 gram, which is 95.78%. When the calcium peroxide dosage was further increased to 1.7 gram, it was observed that the degradation rate reached 93.23% at first 30 minutes. However, it has been decreased to 90.23% at 180 minutes. When the amount of calcium peroxide dosage increased, it resulting in an increase in the generation of hydroxy radical. The dye solution of MB was degraded by hydroxy radical. Hence, the degradation rate of methylene blue is increased. However, beyond the critical dosage, the degradation efficiency shows a reversible direction because of the two factors. The first one is on the concentration of dyes on the surface of the catalyst was limited by the competition of excessive calcium peroxide. Next, it is caused by the scavenging effect of hydrogen peroxide and the recombination of hydroxy radical. Excessive calcium peroxide generated excessive hydrogen peroxide, which in turn will scavenge the reactive species. As you can see from the figure 14, it shows the decolorization of methylene blue at 30 minutes, and at figure 15, it shows the decolorization of methylene blue at 180 minutes. We can see that after 3 hours, it has been slightly decolorized. As you can see at 1.7 gram, it does not show much difference with 1.4 gram. However, we still choose 1.4 gram as the best oxidant dosage because 1.7 gram has shows a decreased result after 180 minutes. Next, the effect of initial pH of ambient solution were carried out on the degradation rate of methylene blue at pH 3, 5, 9, 11, and 13. As we can see, the figure shows that the degradation rate of methylene blue increases with increasing pH of solution up to 9, and above this value of pH, the rate of the degradation of methylene blue starts to decrease. As we can see, when the pH value lowered to 3, the highest degradation rate of MB at 180 minutes is increased to 97.85%. However, as the pH value rose to 13, the highest efficiency degradation rate of MB has been reduced to 79.35%. Obviously, we can say that the decolorization efficiencies of MB and acidic solutions were superior to at the alkaline solutions. This is because in acidic condition, an increase in the rate of degradation is due to the increased availability of hydroxyl ion. Hydroxyl ion will generate more hydroxy radical by combining with holes which will increase the rate of the degradation. Moreover, it was analyzed that the improvement of the decolorization efficiency at acidic condition may be originates from the dissolution of the copper compound, which is catalyst, while in alkaline solution, the degradation efficiency of methylene blue was low, and it might due to the hydroxyl radical was consumed by the scavenging effect of hydrogen ions, and hydrogen peroxide was solvated to form stable oxonium ion when hydrogen ion and H3O2 plus ions were highly concentrated. The formation of hydroxide ions incline to consume much more hydroxy radical and lead to the decline of the degradation efficiency. As you can see from the figure, the decolorization of methylene blue at 180 minutes at pH 3 is almost clear. This shows the highest degradation efficiencies among the three parameters. Lastly, the effect of temperature at 25 degrees Celsius, 30 and 35 degrees Celsius was investigated on the degradation of methylene blue. As shown in figure, the degradation efficiency of methylene blue was increased with the increasing of the reaction temperature. The degradation efficiency of methylene blue was increased from 72.43% to 85.97% within 180 minutes as temperature of solution increased from 25 degrees Celsius to 35 degrees Celsius. In 30 minutes, we can see that the degradation efficiency of methylene blue for 35 degrees Celsius already reached 60.28% as compared to the degradation efficiency for 25 degrees C, which is only reached 40.41%. This is because the degradation rate could be accelerated by increasing temperature, as at higher temperature could supply more energy to conquer the activation energy of reaction and then will increase the reaction rate. However, when the temperature is higher than a certain temperature, the degradation rate is not increased anymore because of the exothermic reaction of molecules. This figure shows the comparison of the decolorization of methylene blue solution at 25 degrees Celsius at 30 minutes and at 180 minutes. From the figure, we can see that after 3 hours, the methylene blue solution was not fully decolorized yet. At 30 degrees Celsius, we can see that the color of methylene blue solution almost turned into clear water after 180 minutes. The same goes at 35 degrees Celsius. The color of methylene blue solution almost turned into clear solution at 180 minutes. This does not show so much difference between the temperature of 30 degrees Celsius and 35 degrees Celsius because the degradation efficiency is almost the same. However, we still choose 30 degrees Celsius as the best temperature considering the energy efficiency and to lower the cost. As for conclusion, calcium peroxide can be a more efficient source of H2O2 than liquid H2O2. This research has proved that methylene blue could be degraded up to 85% by calcium peroxide under the condition of 30 degrees Celsius for a reaction time of 180 minutes with the addition of copper catalyst. The selection of the optimum oxidant dosage, pH and reaction temperature is very important to increase the degradation rate significantly because to prevent the excessive yield of H2O2 and considering an economic efficiency and cost saving. For future research and work, some of the recommendations could be taken such as FTIR analysis should be carried out to identify the functional groups and chemical bonds of methylene blue and calcium peroxide. This result is very important to compare the differences of the FTIR spectrum of calcium peroxide before and after the degradation process. Second, calcium peroxide should be synthesized in nanoparticle size to increase the ratio of surface and speed up the rate of reaction. The third one, encapsulation of calcium peroxide with other materials should be made. This is because in some actual application, the direct addition of calcium peroxide can raise the concentration of hydrogen peroxide to very high level, which is not good. Lastly, in actual practical, the presence of other compounds could affect the reaction mechanism and the efficiency of the degradation process. Hence, extensive research on calcium peroxide should be investigated further to increase the degradation rate. Thank you for your time.